This is a video for AQA Further Pure Mathematics, Algebra and Graphs, section 5.1, Enlargements and Rotations of Conics. You should already be familiar with these curves, which are conic sections, and going through them one at a time. The first one here, of course, is a parabola. Second, the ellipse, and the ellipse crosses the axes, the y-axis, so when x is equal to 0 we get the y values being negative b and b, and then when y is equal to 0 crosses the x-axis at negative a and a. The third one is a hyperbola. And that has asymptotes, remember, which come through the origin in this fashion. And we can find the asymptotes by looking at what happens as x approaches infinity. So the y becomes equal to, or approaches anyway, the value of b over a times x, or this one here is y equals minus b over a x. And finally, we have got the rectangular hyperbola, which has got asymptotes, which are the axes. You should also be able to perform some transformations of conic sections. So for example, here we've got the blue curve, which is the ellipse x squared over 9 plus y squared over 4 equal to 1, which has been transformed in a couple of ways. Firstly, to the red one, where we've interchanged x and y, and this is a reflection in the line y equals x. And secondly, where x has been replaced by x minus 2 and y has been replaced by y plus 1. So this is a translation of the curve by the vector 2, negative 1. So make sure you can do translations, stretches and reflections as you've met in previous videos. If not, do some revision on that before you go on. I want now to look at a couple more types of transformations. The first is an enlargement, and to illustrate that then we're going to look at enlargement scale factor 2. Now by an enlargement we simply mean a stretch by the same scale factor in both the x and the y direction. So remember, if we're stretching by a scale factor, then we divide the relevant variable by that factor. So we're going to get our new equation by transforming x to x over 2 and y going to y over 2. So the new equation is going to be x over 2 all squared divided by 9 plus y over 2 all squared divided by 4 equal to 1. And if we just evaluate that, we then get x squared over 36 plus y squared over 16 is equal to 1. If we now think about the ellipse that produces, we can see that when y is equal to 0, we're going to have x squared equal to 36. So it's going to cross the x-axis at negative 6 and 6. And similarly, when x is equal to 0, then y squared is equal to 16, so it will cross the y-axis at 4 and negative 4. So indeed what we have then is an ellipse looking like this. Quite difficult to draw on this sort of system, but I think you can see that definitely what has happened is that we have then got an enlargement in both directions. by a scale factor of 2. So you can see then what we've done is replaced the values of x by x divided by the scale factor, and similarly for y divided by the scale factor, and then rearranged the equation to give the standard form of an ellipse. The second of the new transformations I'd like to consider then is what happens when we rotate the functions. And to get a rotation, what we need to do is to consider the effect on a general vector. So for example, if we have a vector here which is the vector x, y, and we rotate that by 90 degrees anti-clockwise, it's going to end up over here. And that is going to come to the vector which is negative y, x. Now that tells us what we need to do to produce the new equation. We need to substitute for x, negative y, and for y, x. So therefore, for the equation x, y equal to 4, then substituting those values, we get negative y multiplied by x is equal to 4, which is equivalent to xy is equal to negative 4. And this graph shows the effect of that, and here's our new curve which has been rotated by 90 degrees anti-clockwise. So make sure that you know what happens to the vector xy for each of the different transformations. Multiples of 90 degrees are about the origin. That's the end of this video. In subsequent videos we'll be looking at how we can combine transformations when we're dealing with conic sections.